Okay, a video here about calculating the present value of a bond. We have a 10-year bond payable with a face value of $100,000 and stated interest rate of 8%, paid semi-annually. Market rate of issuance is 10%. So when we're thinking of bonds here, a couple things that we have to keep in mind. First thing is, well, we'll write this here. Number one, we have to find the present value of the face amount of the bond. And number two, we have to find the present value of the interest, and sometimes they call these coupon payments of the bond. Now, the way in which we do this is we use the time value of money. And when we talk about the time value of money, there's a few things here that a couple equations that we need to understand or know. Now, sometimes you'll be able to use a table to calculate these, but other times you won't, and you'll have to know the equation. So, for $1, which would in essence be a lump sum, we look at the future value being equal to the present value multiplied by 1 plus the interest rate to the n power. And n is the number of periods that we're going to have. We can, if you know your algebra, we can rewrite this equation, and we could also say that the present value, if we divide both sides by 1 plus r to the n, we'll get the present value. So the present value is equal to the future value over 1 plus r to the n. Okay, that's for a lump sum. The other thing we have to know is the present value of an ordinary annuity. And when we talk about annuity, annuity is essentially just where we have equal payments or equal disbursements over a period of time, and these disbursements are made periodically. So the present value of an ordinary annuity, we have the payment, which is constant each period, and we're multiplying that by 1 minus 1 over 1 plus the rate to the n power, and this whole thing is over the rate. Now, you may be saying, well, what's the rate? What are the periods? Well, let's look at what we have here. We want to be, at this point, to calculate bonds, we're really concerned with market rate. That's what we want to look at. And we see this being 10%. However, we have to be careful because the interest on these bonds is paid semi-annually. So essentially, we're going to take the rate and divide it by the number of periods or payment periods we have per year. In this case, semi-annually would be twice a year, so our rate for purposes of calculations is going to be our 10% divided by 2, which is 5% per period. And it's very important to know per period. Now, the number of periods that we have, well, how many years is this bond? Well, we know it's a 10-year bond. And if we're paying interest semi-annually, that's twice per year. So the number of periods is however many years we have, which is 10, multiplied by the number of payments per year. So for our n, we're going to have 20. Okay? Now, that being said, let's look at what we get here. We said, number one, we have to find the present value of the face amount of the bond. And we know, if we scroll back up here, the present value is our $100,000. So for the first part, we want to say, okay, we want to know the present value of $100,000 when our rate, and remember our rate here is equal to 5%, when R is equal to decimal equivalent is 0.05, and when N is equal to 20. Because remember, we calculated the number of periods. So to find the present value of $100,000 when R is equal to 0.05 and N is equal to 20, we can use this equation. This is finding present value. So essentially we're going to say the present value is equal to, well, what's our future value? Our future value is the face amount of the bond. So we have 100,000 divided by 1 plus 0.05 to the 20th power, which is 100,000 divided by 1.05 to the 20th power. Now, some calculator action here off screen. 1.05 to the 20th power is, let's see, 2.653. So we're essentially looking at 100,000 divided by 2.653, 2977.05. Never, ever, ever round until you get to a final answer. You will get rounding errors if you do that. So 100,000 divided by 2.6532977.05 gives us $37,688.95. Okay. This is the present value of our $100,000 here. Okay. Now, the second part of this, if you remember, is finding the present value of the coupon payments. So what's our coupon payment? Well, if we scroll back up, we'll see we had what? 8% paid semi-annually. Okay, that 8% is based on the $100,000. Now we're not using market rate here, we're using the coupon rate on the bond because that's what's important to us for calculating the coupon rate. So, scroll for me. The present value of, remember, it's $8,000 per year, but we're paying it semi-annually. So paying it twice per year means we're looking at $4,000 because 8,000 semi-annually would be $4,000. So the present value of $4,000 when the rate is equal to 0.05 and the number of periods is equal to 20. Now, above we can see we have in this area our present value of ordinary annuity or present value of periodic payments, because we're, as the company, we're paying this $4,000 every 6 months to whoever holds the bonds, or $100,000 worth of bonds, we should say. So when we set this up, we're going to be looking at 4,000 multiplied by 1 minus 1 over 1.05 to the n power, and this whole thing is over our rate, which, as we said, was 0.05. So let's look at what we have here. Let's work our and let me change this in. We want to change that to our 20 periods. So let's look at this first. We're going to work on this 1.05 to the 20th power. We did that earlier. We found out that's 2.6532977.05. So I'm going to scroll up here a little bit and we'll work this in steps. We have 4,000 times 1 minus 1 over 2.6532977.05, and we have this whole thing over 0.05. Okay. Now If we go ahead and divide our 1 by our 2.653 number, we will get 0.37688, blah, 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 blah. So we're really looking at 4,000 multiplied by 1 minus 0.3768894,829 over 0.05. Okay. 1 minus our 0.3768894,829 is 0.623. So moving down here, we will have 4,000 multiplied by 0.6231105,171 over 0.05. And now if we divide by 0.05, we get 4,000 multiplied by 12.46221034. And final step here in multiplication means our present value of 4,000 with a rate of 0.05 and 20 periods is $49,848.84. Okay. So this is the present value of those interest payments we're going to be making, those coupon payments of $4,000. Now, if we want to find the present value of the bond, what we do is we take the answer we got here in number 1, this $37,688.95. We add that to our $49,848.84, and let me get back up here so I can see this number. So the present value of the bond is equal to $37,688.95 plus $49,848.84. And when we add those up, we get $87,537.79. This is the present value of this bond. Now, looking at this, this is less than the face value of the bond, which means we're selling this bond at a discount. Because, and think about it this way, if you had $100,000 and could either get 10% for it or 8% for it, most people are always going to pick the higher interest rate. $100,000 at 10% is $10,000 a year. The only reason you would ever take a lower interest rate is if you could pay less for that rate. And that's what we're doing here, essentially. We are looking at discounting that bond, paying less than face value for it, or charging less than face value, because we're paying a lower interest rate that can be gained in the market. So I hope this helps a little bit with calculating present value of bonds. I will have more videos in the future. For now, stay safe, take care, and have a good day.